Our today topic is electric potential energy, potential difference, and absolute potential. What is the absolute potential? Okay. So firstly, start from the defining the electric. Firstly, what is the potential energy? Okay. Okay. When point move from one position to another position, you know that will be you have to do some work. Okay, so this work will be stored. If that is a conservative force, then that work will be depend upon the displacement path. Displacement, not path. If that is non-conservative force, then that will be depend upon the path. And there are two types of forces. One type of the forces is defined as a conservative force. One type of forces is defined as a non-conservative force. If your work is not depending upon the displacement but depending upon the path, that is changing along the path, okay, सिर्फ initial and final point पे ना depend कर रहा हो बल्कि path पे depend कर रहा हो, that kind of the work will be defined as a potential. That type of work will be defined as a that type of force will be defined as a non-conservative force. And if your work depend upon the path, displacement not depend upon the path, it independent from the path, that type of the force will be defined as a conservative force. For conservative force, because in conservative force work depend upon the displacement, so for closed path work will be a zero for a conservative force, because for closed path displacement will be a zero, but for non-conservative force work will be not zero. Okay, that's why जब आप मोटरसाइकिल पे यूनिवर्सिटी आते हो, फिर यूनिवर्सिटी से घर जाते हो तो पाथ क्लोज होता है, लेकिन फिर भी पेट्रोल क्यों खर्च होता है, क्यों एनर्जी कंज्यूम होती है, क्यों वर्क होता है? बिकॉज दैट वर्क इज नॉट that force is a non-conservative force. That's why that work will be depend upon the path कि आपने distance के path mean distance कितना distance cover किया. Generally जो work है वो path पे depend करता है, और close path के लिए work क्या होता है? Zero नहीं होता. Generally work जो है वो zero नहीं है force के लिए, but for conservative force work will be zero for a close path. Okay. So potential energy, if the energy stored in a body due to energy stored in a body due to change in position is defined as potential energy. Okay, that energy will be defined as a potential energy. Okay, energy stored in a body due to change in position, change in its position. Okay, its position will be defined as a potential energy. Okay. And that will be always equal to, and that work is defined as, and that energy will be defined as the work. We know that is the work. Work की definition ही क्या है कि when a distance covered under the action of the force, work क्या होता है? We know that work is distance covered under the action energy consumed when distance covered under the action of distance. I am using the word distance covered under the action of force. Okay. This first is the definition of potential energy. The second is definition of as work. Okay. Okay. So this is the first is the definition of potential energy. The second is work. Both will be equal because both is related to the change in position. So so I may say that the potential energy will be negative of work. Okay, that will be okay, and the potential energy will be equal to minus A to B QE. Okay, that will be this. Okay, and you are moving from A to B, that will be F dot. This is the definition of work. This is क्या distance dl covered under the action. Under the action is dot. You must know why I am using under the action word is dot. Okay. Distance is representing by this dl and force is F and total net is continuous, that is the integration. Okay. For example, if mass moving along this path, okay, and this is position A and this is position B, okay, okay, got it? If this is path L, okay, this path is L, then if F is making angle theta along this path, okay, got it? Then if I represent the first position as RA, this will be RB, yes, and this will be that will be the delta R. Why this is the delta R, I will be proved now. Okay, why this is delta R? This is L and this will be delta R. Why this will be delta R? Because according to head and tail rule. Okay, according to head and tail rule, what is the result? RB is the resultant because tail is joining with the tail and head is joining with the vector of loss vector. So these vectors are adding and these will be resultant. Okay. So RB will be equal to RA plus delta R. So delta R, that's why that will be defined as RB minus RA. So this will be our result. Got it? Okay. But since angle is changing along the path, and we have to consider since angle theta is varying. Theta, angle theta क्या है? Angle between force and path L is varying with passage of time and L is not equal to delta R. Delta R is different and delta L is different. Okay. So we have to divide it into the small patches. So we have to divide L into small patches. Okay. So we will divide it into the and we will divide it into the small patches. Okay. In such a way, W will become a W1, W2, W3 up to Wn, or F dot delta R1. That will be a delta L1. Okay, there is a two different things. This will be a delta L1, this will be delta L2, this will be a delta L3, this will be a delta L4, okay, and so on, and this will be a delta L. Okay, but this cut will be a delta R, okay, and that will be equal to delta R1. Why this is delta? I have already proved that is delta. Okay, that is the change. Delta 1, this will be a delta 1, this will be a delta R2, this will be delta R, sorry, wrong, this will be a delta R3, and this will be, this length will be, this will be delta L, sorry, delta R, Rn, okay. So, you will get okay, but this expression is not true, but this is still wrong. Why? Still wrong because delta L n is not equal to delta R n. Both are different. Okay, they are different for this. And all indices, why I am using indices? Because all LR are different. That is large, that is small. And delta R are also different. And second thing, this distance and this distance is different. This distance and this distance is different. This distance and this distance is different. These are the vectors, okay, but these are the scalars. Because that is the displacement. So that's, there are two things that are different. So that's why they are not the same. Even in their magnitude is not same. Even their nature is not same. One is vector, one is the scalar. Okay. So what we do, what we have to do for this, we have to So for this purpose, that delta Li become delta Li become a delta R, we have to localize it, means the patches must be so small that it approach to 0. If the patches are so small that it approach to 0, then these line will be these curved line become a straight line, and so then this arc length will become like a straight line, and that will be behave like a displacement. Okay, but if we localize, if we localize the path is that delta Li approach to 0. Okay, then delta Li will become a dl. Okay, dl, and that will become a vector. Here that will be a scalar, and that will become a vector displacement, and that will be equal to delta dr. Delta R. Okay, so that become straight line, number 1. Number 2, they all will be identical. So they will be identical. Varying. Since angle between force and path है. So this will be the second thing is that will be identical. Identical means the same. Then if all path is infinitesimal small, then all patches will be identical. Okay. So so W will become so in that case some will be changed. N will be so number of patches will be approach to infinity. Number of patches will become infinity, and this sum I equal to 1 to infinity, that will become integration A to B. Okay. So your work will become, W will become A to B force delta L. That's we have to prove. Okay. So work will be equal to this. Okay. And the potential energy that I have represented by U, or what notation I have used in different, okay, we use the notation U. Okay? That will be a change in potential energy. Okay? That will be equal to minus, because that was equal to minus W था. Minus F dot dl, A to B. We have that was the potential energy. That is not potential, but that is a potential energy. Okay. For that is true. This formula is true for a gravitational potential energy as well as for a electricity, because all the formulas are generally the same, but when we put the values, then that become a for the particular case. Okay. But for electric potential energy, we know that we have already proved that F equal to minus QE. Why I have used the negative? Why the sign, a negative sign comes because For opposite charge they will be attractive. If their force is attractive, then that will be, if there is a repulsive. Acha, that is, I must write the for two different course. If this is for opposite charge. Because negative charges attract, so that's why that will become a negative form. Okay. For same charges, that will be positive for same charge. Okay, got it? So this is your requirement. Okay, so this when we put this value into this, when we put this value into this, then what will be happen? Yes. Potential delta U will be equal to minus QE, that will become a plus for opposite charges. Okay. QE dot dN. Okay. A to B. Okay. And minus plus if Q E A to B. Okay. Identical. ठीक है? The word is identical. ठीक है? The same. Okay. So that will be equal to this. Or UB minus UA QAB E dot delta L. This is actually the change in this is the difference of the potential energy. Okay. So this is also the difference of the potential energy, expression for the potential energy difference. Okay. Okay, got it? But for potential energy, और अब जिस पोटेंशियल, मैंने कहा कि आपको पहले बताया था कि जब भी हम कोई चीज़ पर्टिकुलर से पोटेंशियल एनर्जी की बात करेंगे, देन दैट मीन एब्सोल्यूट पोटेंशियल एनर्जी. पोटेंशियल एनर्जी मीन एब्सोल्यूट पोटेंशियल. दैट इज द पोटेंशियल एनर्जी डिफरेंस between the two states. So what will be the potential energy, or some books write as a absolute potential energy. How you will write this? When something come from infinity to that point, or when charge when charge particle comes from infinity to point, mean is that a approach to infinity, a approach to 0. Okay, that will be defined as the absolute potential energy. Okay, that will be defined as U. Okay. Yes. इसको नहीं, usually we define it as a potential energy. जब भी हम किसी पॉइंट की पे करते हैं, लेकिन आपके इसलिए मैंने रेफरेंस दे दिया क्योंकि आपके ज़माने में एब्सोल्यूट का नाम लफ्ज़ यूज़ किया जाए। जो भी चीज़ है, मतलब वेलोसिटी निकालते हैं तो एब्सोल्यूट वेलोसिटी जिसे आप कहते थे वही वेलोसिटी कहलाती है। एब्सोल्यूट पोटेंशियल एनर्जी से मराद यानी उस पॉइंट पे पोटेंशियल एनर्जी। ओके, गॉट इट? सो दैट्स व्हाई वी विल नॉट मेंशन दैट इज डी आर, so that will be equal to Q infinity to B E dot delta L. This will be expression. Okay. Okay. But what is the E? You know that what is the E? Electric field intensity, and that is equal to that was you have used. Okay. Q prime is like a test charge. Okay, then 1/4 pi epsilon will become out this summa. Q and Q prime. Okay, dr over r square. Okay, infinity to b. Okay, if Q prime is test charge. Okay, like if that is a unique charge. Okay, then this will be equal to this, and the potential energy that will be at infinity. Okay, r square and derivative. Okay, so the function of r and dr. So that will be Q prime 4 pi epsilon r minus 2 minus 1 r की power minus 1 minus 1. Okay, yes, the infinity to rb. Okay, and mu b will be Q and Q prime 4 pi epsilon minus that minus will become out here, and ऊपर वाला mu नहीं sorry mu I have write the mu b because ये हमने तो इंटीग्रेट ही किया है ना, सिंपल इंटीग्रेट. Okay, and you know that I got it r minus 2 plus 1, and that will be equal to minus 2 plus 1, yes, and that will be infinity to RB, RB, you may say B or RB, okay, and so if I write it in the form of B, that is the B, okay, I may write that is because that is potential at the RB point, okay, at so that will be R minus sorry, you may say that minus 1 over R, okay, this minus will become out, and so this become a minus R infinity to RB, and you may say that minus Q prime 4 pi epsilon 1 over RB minus 1 infinity. Infinity means 0. So UP will become minus Q prime 4 pi epsilon 1 over RB. Okay. Or you may say that U, because B is same, so you may the indices B is useless. Okay, so you may write U is potential energy, particular instant potential energy, that will be a minus Q prime 4 pi epsilon 1 over R. This will be a potential. This is a potential energy at point at distance R. Okay. So so what is the potential? Now the new topic was about potential. Potential. What is the potential difference? The that is potential energy per unit charge. Okay. What is the definition of potential? Is potential energy per unit charge, Q, okay? And what is the potential energy? Potential energy, I have already, that is the work. Potential energy is a work, and Q, and that is minus, what was work minus Q minus Q work was a minus plus QE. I was right, plus QE. Yes. It depends upon the if the attractive, then that will be a negative. Force will be a negative. If it be repulsive, then force will be a positive. It depends upon that. Okay. So that means you may write E dot dr divided by Q. Q will be cancelled, and so the potential difference, that is the potential difference, not potential, sorry, difference, like a potential energy. Okay, so potential difference change in potential, that will be equal to this. Okay, so potential difference between 2 points from A to B. That was if we draw a figure, I think already drawn. Yes. Thank you. So I have already drawn it. Now I draw again. So this if point this is point Q. Charge is moving from this is Q prime. Okay. And this Q test charge is moving, but Q will be cancelled. Okay. Now the Q will be not playing any role. Okay. Only this is the source of electric field. Okay. This is the source of, for example, here is a Q. Okay, and this Q prime. Okay, this is a Q. Okay, so this will be the source. So potential difference will be from if this is RB, this sorry, this is RA and this is a RB. Okay, so potential difference will be a, you may write a RA, you may write A and B, or you may write a RA and RB. It's up to you and your RB. Okay, so that will be E dot dr. Only difference is that this charge will be cancelled there. Okay, the test charge will be cancelled. Okay, so that will be equal to this. The as the same in the previous as we have integrated. So so mu and potential. This is a potential difference. Yeah, I mean that is VB minus VA. But what is the potential? For potential, the same as the definition of potential energy. When you move from infinity to infinity, if the reference point is infinity, okay, to that point, that will be potential. So potential, what will be V, as we have done in the same in the previous, that will be infinity to RB, okay, E dot dr. Okay, now A become a infinity, and that will was as same in as we drive, that will be a Q, because Q prime 4 pi epsilon naught 1 over R. This will be equal to this. Okay. Why I am not integrated? Because I have done all this integration. Okay. So may you use this reference. Okay. Okay. This is the expression for a potential. This is a expression for a potential difference, and this is expression for the potential. Okay. Now question is. If Q prime is not a single charge, but collection of number of charges. Okay, if Q prime is not a single charge but collection of collection of different discrete charges. If they are the collection, then the potential will be, net potential will be sum of V1, V2, V3, means sum of the different the collection of different charges, then total potential will be sum of different sum of the potential due to different single charge. Okay, so if they are different potential, then potential will be we have to find this potential of single charges independently. Okay, and then we will sum. Okay, got it, Osama? So so it means so for discrete charge distribution, V will be sum of different the potential due to different single charges. When we will add them, mean that will be a V1 plus V2 plus V3 plus Vn. Okay, sum of the different independent different charges. Okay, the potential due to sum of independent different charges. Okay, we will sum and we may write it in the form of I equal to 1 to n Vi. Okay, and this Vi will be equal to this Qi because different charges will have a different distance from that point. So Ri will be not I. If I say that the distance of please be silent. If for example if this is okay, so one, two, each charge will be have a different first 1 0 2 0, okay, and so on. Okay, like R and 0. In different charges will have a different distance. Okay, so so distance will be different for a different charges. Okay, so that will be not R square, R, because here is R, not R square. Okay, not R, simple R. That's why R. So this will be a expression for discrete. Due to different single charge. Independently we consider the independent charges. Okay. Okay. Now for continuous charge distribution, what will be happen if we consider the continuous charge distribution? Yes, then there will be a different option of the DQs. This sum will be replaced with the integration that will be 1/4 pi epsilon dq. That is also sorry, Qi prime. Yes, I must mention that because this is a prime. That's why I must. So, but we may say that these are I too. Okay, so this dq over Ri 0, sorry, and this will become a R because that will be a continuous, and that will be this. Okay, and this summation will be, for example, the limit of integration will be depend upon from initial to final point. Okay, okay, you may say that Q naught to 0 to Q. Okay, and now it will depend upon the what is the what type of the distribution. There may be a linear charge distribution, that may be a surface charge distribution, like we have discussed this case in the previous exercise. So for 1/4 pi epsilon naught 0 to Q mu alpha d alpha over R or linear charge distribution. Mu is a where mu is mu alpha is linear charge density. I have already explained what is the linear charge density. Okay, so where mu is a linear charge distribution. Okay, it may be a uniform. If that is a uniform, then that will be not function of alpha. That will be a constant. But if that charge density is not uniform, then it will vary with the respect to one variable. That may be r. That may be x. Okay, got it. Similarly. Similarly, for this was for linear charge distribution. Similarly, we will be 1/4 pi epsilon dq. That will be a sigma alpha beta. If the that depending upon that is changing with respect to two variable as we have done in the previous exercises. Okay, then that density will be replaced with the surface charge density. Okay, d alpha, this is double integral d alpha d beta over r. Okay, where sigma alpha beta is a surface charge density, and the integration will be double integration. Okay, okay, and our volume charge distribution, if the charge distribution is a volumetrically, mean if that is closed in some box or a solid sphere or like such, then this will be replaced with the volume integral. Okay, and so that will be replaced with the volume, and volume integration will be volume charge density or density represented by rho alpha beta gamma, and there will be a 3 integration r. Okay, so where rho is alpha beta gamma, that is volume charge density. I have already explained all these things. What is the surface charge density? What is the volume charge density? What is the linear charge density in the previous lecture? So if anyone is missed, what is the meaning of that? They can physically represent how they may represent geometrically or physically, or what is the actual meaning. You may visit that lecture. Okay, that is also available on YouTube. Got it? Anything? So this is all about the so there are two type of expression for electric potential. One is, you may write E dot dr. In exam we may ask about this. This is also there may be a positive or negative, that depend upon the what is the direction. Okay, are they attractive or subtractive? Okay. One is infinity to R. Okay, RB. One expression is this, and the other expression is कॉन्टेस्ट चार्ज. ओके, नॉट बाकी तो आप इस तरीके से देख सकते हो. ठीक है. एंड अदर इज यस yes minus q prime 4 pi epsilon 1 over r. So there are two expression for the single point charge particle. So this and this. Okay, you may write this or this. Okay, so and for different distribution, for if there is summation, then that will be for discrete distribution of charge in the form of this. Summa. For discrete distribution of charge in form of this will be expression. For linear charge distribution this, for surface this, and for volume this. Okay, I think that is all about the electric potential energy and potential. Okay. Okay, electric potential and potential energy. Okay, so